this example, we look into vehicle capacity constraint while performing route optimization. We'll be considering a warehouse flow in which all the vehicles do deliveries while starting and ending their shifts at the warehouse. The vehicle capacity constraint applies to pickup and delivery flow as well. So let's add two drivers or vehicles with their respective capacity. Since it is a warehouse example, all the vehicles start and end at the same location. So over here we can specify the vehicle capacity. Let's keep it to 5 for this vehicle. And let's double it for this driver. So now we create tasks that needs to be done by these agents. While creating tasks, we'll specify the load of each task. In doing so, the system assumes units of load and the vehicle capacity are the same. That means the system does not consider physical dimensions of the task. For example, you can specify the vehicle capacity in terms of number of boxes, kgs, etc. The unit of load also needs to be the same. So for agent 1, we've specified the unit as, let's say, boxes. So the agent 1 can carry 5 boxes. That is the capacity of its vehicle. The agent 2 can carry 10 boxes. This is the capacity of agent 2's vehicle. Now let's add some tasks for these agents. While creating a task, we can specify the load of that particular task. Let's say we have to pick up an item, or in this case, deliver an item which has a load of 2 units. Similarly, let me create some more tasks. As you can see, I have created 4 tasks, and each task has a different load attached to it. Let's see. Here you can see the load of each task: 2, 3, 6, and 4. Now let's optimize the solution. So as you can see, all the tasks are optimized and the vehicles obeyed their vehicle capacity while going for the delivery.